Okay, so hello everyone. This is our fourth lesson in modding. I'm going to be covering entities today. I'm Kat. I'm a fourth year cybersecurity major. I've been doing modding for 8 years, and so let's just jump right into this. So first, we're going to do a little overview of what entities are and what they do in Minecraft. So entities are unique units that are tied to a level. They can change their position and rotation. So things like pigs, armor stands, item frames, anything that's not a block or item that exists in the world and moves around. They don't always move necessarily, but they can exist outside the context of a block. So unlike blocks and items, they handle their own state, which means that they can store their own data on their own instance. They have a type, so they're unique, basically. They have a type which provides their unique ID, how they're created so that they can spawn, and any other generic metadata that's like tied to the type of entity rather than a specific entity. They have specialized renderers, which let them do more complex shapes than blocks can typically do, and can be more dynamic. So like an item frame can render an item inside of it. So there's different kinds of entities. These are within the Java code. So all entities are underneath the class entity. I know, so crazy, but those have type, position, rotation, velocity stored on it. And then anything living that has health or can take damage would be a living entity. Almost everything that has an AI will extend mob, and then also Pathfinder mob. So the only exceptions there you'll see, but most mobs extend Pathfinder mob. Pathfinder mobs have AI goals. They can move and look around on their own. They can navigate paths around objects, and they can attack targets. And you have ageable mob, which adds the ability to be a baby. So like pigs and stuff will extend that. And then furthermore, you have animal, which adds breeding code. So pigs also use that. The only one thing that is ageable but not an animal is villagers, because they don't use the same breeding code. And then you have monsters. They extend monster, and that adds a bunch of hostile mob related stuff like XP, sleeping. So, and then this is a more like visual view of the type hierarchy of entities in Minecraft. So everything here extends entity, and you have things like projectiles and vehicles and item frames and stuff like that that are just entities. And then underneath that you have living entities, and so underneath living entities there's players, armor stands, and then mob, everything under mob. So those are the three types of living entity. And then under mob you got flying mob, which is ghasts and phantoms. And the reason they're not Pathfinder mobs, but they're mobs, is because they actually don't do any pathfinding. Bats just fly in a random direction. Phantoms can fly through blocks, so they don't need pathfinding. And ghasts sort of exist in a large open space, so they don't usually need to pathfind. And then you have Pathfinder mobs, which are usually stuff that walks on the ground or in water. And most like typical stuff with AI will be a Pathfinder mob. And then under Pathfinder mobs, you have monsters, water animals, and ageable mobs. So water animals is anything that's in the water. Monsters are the evil creatures that kill you. And ageable mob will have animals and tameable animals underneath there. So those are the generic types that you typically see and that you can add to. So now the concept of entity types. So every entity that exists that has like a class needs to be associated with one or more entity types. So the entity type is what is actually added to the registry for entities, and it describes the basic metadata about the entity, how to create it, and that sort of thing. So without entity types, your entity class is just sitting there being useless. They tell it how to be created. So they also contain a couple extra pieces of metadata. They have a mob category, which describes usually like how it spawns or behaves in relationship to the game. So like, for example, monsters can like despawn while creatures can't. That's a very vast oversimplification, but those mob categories are important in a few places. You have the client tracking range and update interval, which is like how the server communicates packets about that type of entity. The size, which is the hitbox, and that can vary inside the entity, but that sets the base size. And then if it's immune to fire, if it can be summoned with a /summon command, if it should be persistent. So for example, bats are ambient creatures, and they are not persistent. They actually don't write bats to the disk when you exit the game. They all just disappear. They don't exist anymore. They're not persistent. And if it can spawn far from the player. So creatures, for example, can spawn, like, they spawn with chunks, while monsters spawn in a circle around the player. So that's the difference there. And then the entity's ID, which is how its unique ID in the registry. So to create entity types, use the entity type builder. And all entity types are generic instances of entity type. So if you haven't studied the Java concept of generics, it's basically like a templating system where you can vary the type definitions inside a class. So like you can have something return, instead of returning like pig, it returns t. And then that t is like an argument. So then when you create an entity type with pig inside of it, it replaces all the instances of t with pig so that you can have like generic classes that vary based on type. The builder, a builder is basically a collection of methods that help create the object versus just calling its constructor like new entity type. And so you can create those with entitytype.builder.of, which we will do in our demo. And then you can call any relevant methods like setting the size or if it's immune to fire, that sort of thing. And then you put .build, and then it builds it into an actual entity type, which you can then register. So that's entity types. So now we're going to register an entity type. Let's do this. So if you have your source code, so we're going to create a new class called mod entities, similar to mod blocks and mod items, and just make a deferred register the same way we would for anything else. So I'm just going to copy this from the block. So now we have a deferred register for entities, and then we have to tell the mod class to subscribe to it. Cool. So now we can register entities to it. So the thing with entity types is because they're generic types and Java's generic type system is a mess. You actually have to create a function to do this because otherwise it just doesn't like to work. So if you go to entity type, where they're actually registered, you can see these are all like, this is how vanilla creates them. So like it's setting size, eye height, that sort of thing. But if we go to this register function here, this does some stuff. We need to steal this because otherwise the types get really messy. So you'll see we actually want to return a deferred holder because that is the type that is used. And then I think deferred holders go in the other, yeah, they go the other way around. So it's question mark there. So then register, then a builder, cool. And then you can do entities dot register the key. That should do it. Yes. So now we can create the correct things. So do public static final deferred holder. And then we need to actually create an entity to register. So I'm going to create another package called entities and create a new class for it. I don't know what our entity should be. We should add an animal. What kind of animal do you want to add? Any input, guys? A monitor lizard? Sure, I can't model that, but it's sure. We're just going to do lizard.
A duck.
A duck. I think I've done a duck before, actually. But we're going to do lizard. So lizard entity extends, and then we want it to be an animal because that's probably the best place for it to fit. And we just need to implement the methods on it. And we're just going to leave them unimplemented because I don't care. And then create the constructor. So entities actually have two constructors. There's one that accepts an entity type. This one is used by the game to like actually create the entities when they load. But usually entities also have a second constructor, which is, this should be public too, which will be like just the level, and then you pass the actual entity type here. So it would be mod entities dot lizard dot get, which we haven't actually made yet, so it will just error, but that will do that. Lizard. So we need entity type lizard. Equals new. Nope, it does not equal new. It equals lizard with an entity type dot builder dot of. And then I think you need to pass it entity factory, so the lizard entity. So this is a method reference. We're basically telling the game how to construct it using the new method. And we give it a mob category, which will be creature, because that's what most animals use. If you look at the pig, for example, it'll be using creature. So technically that's all we need there, but we're gonna also give it a size. So I think the lizard will probably be about 0.25 blocks wide, maybe 0.35, yeah. And then it'll be like 0.2 blocks high. That's our lizard. It's pretty short. Maybe we'll make, yeah, I think that's good. And we need to give it an eye height, which will be like 0.18, which is almost its full height. And then that should create the lizard. So now that our lizard is registered, it should actually exist in the game. Oh, it's giving me generic type hell. Please don't do this to me. Okay, it is doing it. So, yeah, this is a problem I ran into earlier. I had to do so much generic type coercion. Okay, hold on. So I would highly recommend just stealing this function from me because it hates me. What is it? What's the type of what it wants? Entity factory. Okay. Okay, so now we've got it actually working. This should theoretically fix the generic type hell that we're in by doing this. Boom, I've solved generic type hell. It's a very large function, which I am now going to paste into the Discord because this thing is terrible. Otherwise, the JVM just doesn't know how to resolve types, which is the problem we just ran into. It hates wildcards. I don't know why, but it really likes when you put them in functions instead. So that's what we're doing. So now that we've registered our lizard, it should theoretically exist in the game. So I will boot it up. Oh, thank God. Okay, yeah, that was it. So Gradle sometimes decides to be a stupid idiot and not compile your changes. Okay, so the issue was that it just wasn't syncing with Gradle, so I had to reload the project. But now it's there, and it's unable to summon the entity because I haven't done the work to make it a functional entity. So if you look at the logs, it's going to say, cannot invoke attribute supplier.getValue. That's because we haven't registered any attributes. So now if we continue with our presentation, now that we have a working entity, so attributes. Attributes are specific modifiable attributes that affect how an entity interacts with the world. So an example would be their maximum health or their move speed. So they're used by living entities. They have base values which describe what they typically spawn with, and then they can vary either temporarily or permanently through the use of modifiers. And your base attribute values are tied to the entity type rather than the actual entity's class. So some more examples, you got attack damage, their follow range, their knockback resistance, jump height. And a big example of this is horses change their attributes a lot. You can get different horses with different jump heights, that sort of thing. Baby mobs move faster, and potions can mess with your attributes. If you take a potion of absorption, you have a higher max health. So in terms of registering entity attributes, the base ones for your entity type, they're tied to entity types and they need to be registered alongside your entity type, but not in the builder. They have their own special thing that vanilla uses. It's in the class default attributes. And they very rudely used an immutable map, which means it's immutable. It cannot be changed or added to. So how rude of them. But luckily for us, yeah, this is what it looks like. Luckily for us, there's mod APIs, so we can use Fabric and Forge to accomplish this. So most of the time, the actual attributes are written as a static method inside your entity class called create attributes. So if you look there, that's an example of the bats attributes. It uses the mob's base attributes and then adds the max health with a base value of 6. So registering, there's two different. For each modding API, I've included what the API is to register to entity attributes. We're using NeoForge, so it's going to be the entity attribute creation event, which has an event. You have to subscribe to it like any other thing. Attribute suppliers are usually inherited from living entity, mob, or monster. Those are the three base attributes. So if you look here, you got living entity, which includes basically all of them. You got health, move speed, all the things that any living entity would use. And then you have mobs, which add the follow range one. That's important for AI because that determines how far they follow you from. Like a zombie, if it sees you, its follow range just determines how far away. And then monster adds the attack damage attribute. So you got three methods on the attribute supplier.builder. You have add, which just adds the attribute with its default value, and then you have add with a value, which adds it with a custom value, and then build, which actually builds it and lets it be used. So if you look here, you have entity type, create attributes, build. And then you can also see create attributes, add. So those are the two things you'll typically be doing. So now we're going to add attributes to our entity. So for NeoForge, you have to subscribe to the entity attributes creation event. So we're going to do that. So if you remember, that's how you subscribe an event statically, but we need to actually tell it that this method, that this class has subscribers in it. So we need to give it our mod ID and then give it the bus, which I believe is on the mod bus. Let me check. Used to register, it's fired on the mod bus. So yes, we need the mod bus there. So now we have the entity attributes event. We can to .put. And then we have mod entities, lizard, and then we need to actually create an attribute supplier for our lizard. So if we go to the lizard entity, we can do it the same as literally any other entity. Call it create attributes. And then it's not going to return void, it's going to return an attribute supplier.builder. And then we'll return mob, because that adds the follow range, which we're going to want. Create mob attributes. I don't know why it wants to use ageable mob when I should be using mob. We add. And then we're going to want to set the health, I think. So attributes.health. And we're going to make it have, so 1 health is half a heart. So how many hearts? I'd say like 6. So 12 is our value there. And then I think that's all I'm going to, I might increase the move speed because lizards are pretty quick. Yeah. Oop. So we're going to make it move, say, 1.5 blocks per second. Hi.
Hello.
Feel free to have a seat. We're just working on attributes right now. So now that we have our create attributes method, we just put that onto the registration over here. So it's lizard entity.createAttributes.build. And now we have added attributes to our entity. Hooray for our lizard. Our poor little lizard guy. So now we should theoretically be able to summon our entity, but I know that's not true because it's not going to work. But it's going to conveniently segue to the next part. So this next part's really cool. So now if we do /summon cat mod lizard, and it crashes. Why does it crash? Because we haven't done another very important thing. So if you look here, the crash says, cannot invoke renderer.shouldRender because EntityRenderer is null. And that's because we haven't told the game how to render our entity and how to display it. So it exists on the server, but the client gets very mad because it has no way to display it. So that conveniently segues us to entity rendering. So a little bit of an introduction to 3D graphics. I know, riveting, isn't it? So Minecraft is built on LWJGL's OpenGL APIs. That's a mouthful. LWJGL stands for Lightweight Java Game Library. It's what Notch so wisely decided to use when creating the game. And then OpenGL is a graphics API. So a graphics API is a system of methods and variables that are used to interact with a graphics card and display graphics on a screen. It's implemented on the GPU, software can call it, and it renders 2D and 3D vectors into pixels. So they're a little bit complex, but I can simplify them. So basically the way a 3D graphics pipeline works is you have a buffer of vertices, or a vertex in the singular form. That's the corner of a triangle. And so each of these vertices have a 3-dimensional position that describe a plane between them. So you have a triangle, and it has a plane inside of it. So those vertices, when you specify them in the right order, they form a flat triangular surface between the 3 points, so a plane. And then joining those triangles together can make more complex shapes. So you can make 2 triangles to make a square, and then 6 of those to make a cube. And so they're placed in a 3D space by using translation, rotation, and scaling relative to the world coordinates. And then you order those shapes by their distance from the camera, which is a single viewpoint, and project that image onto a flat plane, very much like a camera. And then you take those vectors, because they're just basically numbers at this point, and then you rasterize them, which is the process of converting them into distinct fragments, or in this case, pixels, that are then displayed on a monitor. So OpenGL has a concept called the stack. The stack describes the transformation of the current rendering matrix. So basically, you can have different objects drawn in the world, and when you draw them, they exist at a certain point in the matrix that's described by translations, rotations, and scales. And so to move something 2 blocks to the right, you can translate it by 2. Or to make something twice as large, you can scale it by 2. That's how the matrix works. So with this matrix, you can sort of isolate different things that you're rendering by pushing and popping the stack. So the stack is the same as the concept in computer science, if you're familiar. It has a stack of things, which in this case are transformations to the matrix, and then you can add the things to it, so push, or take something off the top that you just added to it, so that's a pop. And so in the case of OpenGL, when you push, you're actually saving the current state of the matrix onto the stack for later use. So then you can do, once you push, you can render something, or you push, you make changes to the stack, like translating, you render something, and then you pop. So popping it would restore this thing that you pushed earlier. So it would return the matrix to its original state. So this graphic's a little bit misleading, but you're basically saving the state and then restoring it. This lets you render different things without leaking the... So like if I were to want to render something 2 blocks to the right, and I render it, and then I don't put the matrix back, everything else that rendered after that would render 2 blocks to the right. So that's why you pop it, which restores the matrix to its original state. This is important, I promise. Why are we learning about OpenGL? So every visual element in Minecraft, literally everything that you see in the game window, is an abstracted version of OpenGL calls. Everything is displayed with OpenGL. And you would see nothing if there was no OpenGL. So entities in particular have a lot more access to OpenGL because they're more customizable versus blocks where you just have a JSON model and that's it. So most interaction with OpenGL is just pushing the stack, making an adjustment, and then popping it. That's all you really do. So now going into actual entity rendering in Minecraft, there's a concept called layer definitions. So layer definitions, basically the game splits models into different layers that you can reuse at different points inside of different entities. But most of the time, one entity will have one layer. And the layer describes all of the cubes required to render the model. So Minecraft actually stores its models for entities in Java source code. It's not like any specialized format or .obj files like other 3D modeling. It's just Java source code. So everything is function calls that add cubes to things. You'll see in a second here. But so the layer definitions contain the name, which each cube has a name, which describes a unique ID for it, its position, size, and rotation, and then you have a offset, which is its pivot point, the pivot point of my arm is the middle versus the pivot point wouldn't be my fingers. Things don't turn around that. So it's the rotate point around which things rotate. And then the texture offset, which describes where the texture should be drawn from, and then their relationship to each other. So you can actually parent cubes to other cubes. So if I were modeling my arm, my hand would be my hand's parent would be my forearm, so that they apply their own rotations to each other. And then they define a texture size, which is the canvas size, and they are usually stored as a static method inside the model. So you'll look here. So you have Blockbench. Blockbench can create these models for you. So if you want to actually create a model, you do it in Blockbench. And then on the bottom there, you have what is an actual layer definition for that one single cube. So it's a 1 by 1 by 1 cube at 0, 0, 0. And so that's what the layer definition looks like. It's Java source code. I hate it, but it is what it is. So you have a cube. It adds a cube named BB main, and then sets the texture offsets, and then creates a box with a size of 1. And then it sets the texture canvas size at the very bottom there. So it's 16 by 16. So then you have the concept of an entity model. So these basically wrap layer definitions in a more customizable format. So a layer definition describes a static model that can be rendered once or multiple times. A model adds the ability to animate them and mix them and do whatever you want with them. So they have things called model parts in them, which are cubes. It's the same thing as the cubes from the layer definition, but they're animatable, meaning you can change their rotation, size, that sort of thing. And they provide a lot of functions for animating and rendering. So you have render to buffer, which is the main thing that actually draws the cubes. So if you look at a blockbench model, it's going to generate that function with the main cube being rendered. And then set up anim, which lets you do actual animations. And you have the concept of flyweights also applies to models the same way it does to blocks and items. So each entity or entity type will have one instance of the model class. That means that you can't store state, like you can't store something related to a specific entity inside the model because they will leak between different entities of the same type. So you can put fields on the entity itself and then just reference them from the model. So this is what an entity model looks like on the inside. You have a class that extends entity model. At the very top there, it describes a model layer location, which I'll go into later, but that's very important. It's used to register the layer definition. So that can actually be stored anywhere, but Blockbench likes to put them in there for you. And then you have the model part, which I've connected as a line together to show you where it's being referenced. So the constructor there receives the model part, and then it gets put into that field. And then later in render to buffer, the field is rendered. And then you have the layer definition there, and then set up anim, which right now is empty. Now you have the concept of an entity renderer. So these entity renderers are what actually tie models, textures, and then the entity type together. It puts them all together into one thing. So they provide additional context and functionality. They usually extend mob renderer for anything with AI. Other things will be using entity renderer, but mob renderer is what we're going to use. So if you look at the constructor there, it's calling super, right? The second argument there is very important. That's what actually tells it what model to use. So we're creating a cow model. This is the cow's renderer. And then providing it the layer definition. So layer definitions in Minecraft are baked. So it provides the model, and then it passes the baked version of the layer definition to it, which creates the model part that we see earlier right here. So this model part here is coming from right here. And then this is the shadow size, which I will show you what that is, what that actually is in the next slide. But that's how you specify the shadow size. And then you have the get texture location method, which lets you set the resource location that's used to draw the texture from to render the entity. And so also important when you're doing get texture location, you really don't want to return a new resource location because that method gets called like 60 times a second. And you'd be allocating a lot of memory. So that's why you create a field and then pass the field to it. So entity renderers also have a few other useful methods, which like scale. So scale lets you adjust, it lets you apply OpenGL transformations right before the model is actually rendered. So most of the time it's used for scaling, which is why it's called scale. If you want to make something twice as large or something like that. And then add layer. So there's another thing called layer. These are rendered layers, not layer definitions, different things. And those let you attach like additional renderers to a renderer. So like pigs use it for their saddle, or foxes use it for the item they're holding in their mouth. That's a render layer. And also, as I mentioned, this is a 0.7 block shadow diameter. So that's what the shadow size is. It's that black circle that's specified right here. So in terms of actually registering a layer definition, you do have to register them. Crazy, I know, but that's because they're pre-computed, they're baked. So baking is a process in which the GPU pre-calculates the lighting and display operations to make a model show in the world. So it makes it basically faster at the cost of upfront computation. So you register layer definitions using the modding API because they so wisely used another immutable map or something like that. I don't know. So they associate with model layer locations, which are basically a wrapper around resource locations. I don't know why they made that. They could have just used a resource location, but model layer location. And then when you actually call bake layer, you just pass it the model layer location. So if you look here, this is a model layer location that's being passed to bake layer. And then if you look at the cow model, it would have the actual definition for that layer definition. I feel like I'm speaking in tongues. Layer for layer definition, model bake. Thank you. So, and then to register an entity renderer, you associate an entity type with the entity renderer. And you give it gives you a fun little thing called the EntityRenderer provider.context, which is used to bake the layers. So if you look back here again, this context thing here, that's used to bake layers. It's so complicated, but in NeoForge, that is EntityRenderers event.register renderers. And then there's a function on that called register entity renderer. Ugh, I'm gonna die. So tying this all this nonsense together, first you have the renderer being created. So the entity type does a registry lookup to find the associated entity renderer and then constructs it. The entity renderer receives the entity render provider.context, which can bake layer definitions that are in the registry. And then you associate a layer definition. So layer definitions are registered with the model layer location that's stored inside of the entity model. The layer definition is provided inside the entity model and then registered with that model layer location, so that associates those two together. And then your renderer creates an entity model by providing it the baked layer definition, and then that entity model wraps the layer, it lets you animate it, and then you can render it. So the entity renderer stores that model, calls render to buffer, which displays it in the game. Hooray. Crazy complicated stupidness. So now we're going to create one, because that's going to be way more valuable than whatever nonsense I just said for 15 minutes. So the first thing is, we haven't actually done any client-only code in this mod yet, but if you remember from my lecture on sidedness, you really don't want to put client code inside your common shared code, or it'll crash on the server. So we're going to make a new package called client here that is going to hold all of our client code. So now we can create the client version of our mod. Well, not really the client version of the mod, but a class to hold all the client stuff. So first we're going to make this an event bus subscriber. And we're going to subscribe it with the mod ID. So if you remember, we can reference client-only code. We can reference non-client code inside the client, but we don't want to do client code inside the, inside the common code. But the two events we need are the layer definition event and the entity renderer event. So we're gonna do register layer definitions. Nope. Yes, there we go. So that's the event that we're listening to for layer definitions. And then we need another one for entity renderers. So the great thing is we actually don't have a model or a layer definition to render yet, so we're going to create one. We're going to make a lizard, guys. You excited? So we're going to open Blockbench. And inside of Blockbench, we are going to create a modded entity right here. Yeah.
In a good way. All the good.
So we're going to name it lizard entity, and the model identifier is going to be lizard. And we're going to leave it as Forge 1.17 Moj maps because that's what we're using. And we're going to increase the texture size to 32 by 32 so that we have some room. And then, wow, we have a lizard entity. We're also going to save project as lizard entity. Okay. So now we can add cubes. Our lizard is going to be dirt simple because I am not an artist. But we can use the resize tool to make it a body. Let's make it a little bit wider. What? The cannon? You like the cannon? Okay. So the great thing about entities is that they actually don't have to exist within the bounds of a block. I can make this as large or as small as I'd like, and we can also resize it so that it's actually smaller than, so right now this would be a block, right? A block long. But I can actually make this same amount of detail fit inside of half a block because of the power of OpenGL. So I can actually make this a little bigger than I would like it to be in the world. Because we made its hitbox like 0.35 blocks tall, right? But this is already taller than, almost as tall as that. And it still doesn't have a head. So we're going to name this one the body. And then we're going to add another cube underneath the body. So this is how you associate the cubes with each other, if it would let me. No? Okay, hold on. I have no idea. All right, well, we're just not going to bother with parenting stuff correctly, and we're just going to add the head like this. Oh, that's the wrong way. So this is our lizard head. That's our lizard tail. It looks like a leg, but you know what? It's fine. This is our lizard boy. He's so cute. So now I'm going to set the pivot points so that these will actually... So if you notice there, when I select it, notice how it has that little red, green, blue thing right there? If it would let me move. So that's the pivot point. So if I change this, you can see the pivot moving. And I actually think that's the perfect pivot point. That's where I wanted it. But these ones have the pivot point on the front. I'm going to move their pivot point back so that their legs will pivot around that little square there. Yeah. So you can now see the pivot points are exactly where I want them. I'm going to move them up though because they should be in the middle of the leg, not at the bottom of the leg. That's so that when it rotates, so I'll show you in a second, if I rotate these, the pivot point changes how they rotate. So if I rotate them, see? But if I move the pivot point, it would be rotating around a different point. So the way I want these lizards to actually move is like this, I think. That's how a lizard would crawl, I believe. I don't know. Oops, I did not mean to do that. So like, yeah, I'll just do something like that, I think. Alternating, like this. So that's our little lizard. So now if we export him, we can create a texture too. So this will be just a blank version basically, so that I can actually, so it'll just look like that in the game, but I think that's okay. So you got lizard.png, and then now if you go to export Java entity, and then you can do lizard.java. So I'm going to name it lizard model, actually. I think, yeah. So now we've got lizard model and lizard.png, we can open up the project. And I'm actually going to put the Blockbench stuff in here too. We can open up the project here. Go to source, main, Java, client, and we can go models, and then put the lizard model in there, and we take the texture and we put it in resources, assets, catmod textures, and then entity. And then paster right in there. So now if we go into IntelliJ, we will now have our models in here, and we're going to create another package called renderers, and put models inside there. It's just how I like to do things. And make a new class called LizardRenderer as well, and then move this to the right package because it created it inside the wrong one. There we go. So if we open the lizard model, we'll notice that it is named incorrectly. And it doesn't have a package definition, so we're going to do package dev.itsmeow.catmod.client.renderers.models. And then we're going to change the name to lizard model. And then we need to replace all the t-extents entity with lizard entity, so that this lets us basically reference the fields inside the lizard rather than just the generic entity ones inside right here. That's what this is. So we can change this to lizard entity now. And we're going to do, nothing is imported for some horrible reason, so I have to import all this stuff. I'm pressing Alt-Enter, by the way. That's what's doing all the importing currently. We need to change the constructor. And I'm going to change BB main to root because that's how I like to name it. So you'll see here pose stack. This is what actually, that's the GL state. That's the matrix there that I was describing earlier. And then this is the model layer location. So we're going to need this for registration. So it's going to be catmod.modID for our lizard. And then it's also not new resource location anymore. It's resource location dot, I think from namespace and path. So hooray for that one. Our render to buffer is apparently wrong. I guess they changed the method signature and didn't. Blockbench is a little bit outdated in that matter, so we need to give it the right stuff there. There we go. So there's our fields. Here's our layer definition. Lizard model. So this should be a functional model now. So if I go to lizard renderer and then I make this extend mob renderer and do lizard entity, and then you need to give it a model, so it's going to be lizard model, and then that is also a lizard entity. Generic type hell. That's why I was saying you really do need to know generic types for this. They're very important. So now we have this same structure that we saw earlier. We're gonna want to get the right texture, so we're gonna do public stack final resource location lizard texture equals resource location dot from namespace and path catmod.modID, and then it's textures entity lizard .png. That is actually correct. I'm gonna just make sure by going to cow renderer, right? I like checking. There should be a .png there. So last time we had a problem where we put .png and we weren't supposed to. This one does want the PNG. So then we need to pass it a model, and a shadow radius. Those should not be there. So the model will be new lizard model, and then we're going to pass it context.bakeLayer, and then we have lizard model dot lizard layer. And then we're going to give it a shadow size, which I think will be 0.25. And then right here we need to give it the right texture. And lastly, I want to scale the lizard so it's a little smaller. So we can actually do that right here in render to buffer. So if we do pose stack dot push, push pose, right? That'll save the current one to the stack, and then we also need pose stack dot pop. So that will restore it, and then we can do whatever transformations we want right here. So we're gonna do a scale. Actually, I think we need to scale it inside the renderer because at this point the model's already been rotated and stuff. It might affect how it scales. So I'm gonna do it in here actually. So there's this function scale. So if you look at the parent definition, it's empty, so we don't need to do super or anything. We can just do pose stack dot scale. And then I'm going to do 0.5, I think is probably good. Half as large. And you don't need to push or pop because the game already does it for you at this point. So that's why I haven't done it. So that is our lizard renderer. And so now we need to register both the renderer and the layer definition here. So first I'm going to register the layer definition. It's lizard model dot lizard layer, and then we need to give it a supplier of layer definition. So we can just do lizard model create body layer, and that's it. That's a method reference right there. And now we can register our entity renderer, which we will be using the entity type. And then we need to provide it a new lizard renderer. Did I make this abstract? No. Okay. How about, actually, we can just do lizard renderer. Yep, there we go. So now we've registered the layer definitions and the entity renderers. You'll notice that this is cat mod with a mod bus. This shouldn't load. Hold on. I believe event bus subscriber has a side field. No. I'm worried this will load on the server. I don't think it will. I could do only in, but I'm not going to do that. Okay, so that is our client. Steps done. We have a renderer, we have a model, it's registered, it has a texture. So I believe that if we open the game, our lizard will render. So let's do it.
I know I missed parts of the beginning, but did you have like a spawn item to, or like any kind of trigger?
We're just going to be using /summon.
Oh, okay. Perfect.
So I didn't have time to get to spawn eggs in this presentation. It is at the very end of my slides, but I only had a week to make this.
I forgot about this.
And I'm a very busy person. I was at work just writing up about entities. Oh, it crashed. How fun. Why is that? Cannot invoke should render because renderer is null. But we registered it. Oh man. Am I forgetting something? Hold on. Hold on. Oh, okay. I apparently forgot that that existed. If you can put a mod. No, that's not correct. A separate mod annotation. Okay. Yeah, so if I put cat mod, I can put a mod annotation on this. And that means it'll get class loaded by the game when it's loading on the client, but only the client. So now this will actually load. So what was happening is this wasn't loading, I think. Oh, I also that's why. I forgot to put subscribe event. That's actually what happened, I think. So I didn't need the mod annotation. I think it was still loading, but I'm actually gonna convert these from static subscribers to non-static ones so that I don't need this. So you can do mod bus dot register, or no, add listener. And then this register layer definitions. You can also do the same thing here with register entity renderers. So now both of those will be called by the mod initializer rather than using static annotations. Those are the two different ways you could subscribe an event. I'm just doing the other one. I think it'll work better. From a sightedness perspective, I love sightedness. Basically, we're doing that so that when you run the dedicated server, it doesn't crash and lose its stuff. Okay, so now if we do /summon catmod lizard, there it is! It's so cute. If you look at the hitbox, it fits perfectly. So they're not doing literally anything because they have no AI and no texture. So they're just gonna sit there and die. They have a lot of health actually.
Wait.
Summon a lot?
Yeah.
Yes, entity cramming. Entity cramming in action.
Yeah, they're getting crammed because there's so many of them. Oh, that's much better. I have a river. Hold on. Put the cannon. The cannon. Oh, wait. Oh, that just it can't hit entities. It can only hit blocks. But now they're spreading. They're still cramming. You want me to? Oh, wait. I got a better idea. Oh, that's cruel. That is cruel, guys. You just made me blow them all up. How could you do this? This was your fault. It was your idea. It was all your idea. I have no say in this whatsoever.
Yeah.
You know what? Actually, one of my favorite Minecraft mods is like the little tiny villagers mod.
Oh god. Gulvers?
Gulvers.
Yeah.
Yes. This reminds me of that. You could have lizard army. Give them the like wolf eye.
Yeah, okay. We're not gonna do that, but So our lizards are rendering. This is awesome news. So now we get to move into the next part, which is the part I didn't finish, but it's okay because we're going to finish it on the fly. AI! How to make the lizards do things, guys, because we're tired of them just sitting there. So, little overview of AI in Minecraft. Anything that's a mob performs autonomous behaviors like wandering, attacking, following, and they're all triggered by environmental conditions. So it's not really AI, it's just simple logic. So they switch between various tasks depending on their conditions. So if a zombie sees the player, it follows the player. If it runs into a door, it breaks it. If it's close enough to the player, it attacks. And if there's no players, it wanders around aimlessly. So goals. Goals are the main way in which Minecraft accomplishes AI. So they drive entity behavior by encapsulating a couple things. You get the conditions required to execute, the conditions required to end its execution of the goal, the actual behavior to execute during, before, and after the goal, and then any like exclusions with other goals. So they have these exclusion flags: move, look, jump, and target. So you can only have one goal with each type of exclusion flag at the same time. Because you can't be both wandering and following something at the same time. It's just not possible. You'd be very conflicted. So those are exclusion flags. So here are some common goals. There's already goals to do a lot of very common things in Minecraft, so you don't usually have to make any unless you're doing some cool, complicated stuff. So for targeting, you have the hurt by target goal, which attacks whatever attacked you. Nearest attackable target goal, which is what most things use, like zombies, look for players and villagers. You have the move types, which we have random stroll and water avoiding random stroll. Those are the wandering goals. Those are very useful. You have float goal, which is on basically everything. If it falls in water, it just swims like a cow in water. They just sit there and go up. Otherwise, they would just sink. You have, yes, you have the avoid entity goal, move to block, follow parent, panic, which is what the farm animals do when you hit them. They run around like crazy. You have tempt goal. There's also a goal called run around like crazy goal, actually. That is real. It's used by horses. It's basically the same thing as panic goal, but for horses, because they can jump. You have tempt goal, which is what, like if you hold wheat near a cow, it follows you. That's tempting. You have melee attack, which is a very common attack goal. You have ranged attack goal, which is used by like witches. And then bow attack goal, which is used by skeletons. You have look goals, you have look at player, and random look around. Those two are also pretty common. So this is where I didn't finish my presentation. We're adding goals to entities. So we'll now do a live demonstration and consider this what I was intending originally. So our live demonstration, if we go to lizard entity, we can see there's methods here. So there's a method called register goals. So this method is where you specify what goals the entity will be using. And you'll see it in the base class, it's totally empty. But if we do this dot add goal, or is it register goal? Hold on. Goal selector dot add goal. Yeah, so the goal selector is what chooses between which goals you're going to run. Every goal that you add to an entity has a priority, which is a number that describes its priority. So it will first try to run in order of priority each goal. So each goal has a method on it called canExecute. So it goes through all the goals by priority, checks if they can execute, and then if they're ready to execute, executes them. And then it adds that goal's exclusion flags to the list of like goals that can't run anymore. So the first thing we usually want to do is a float goal. So most goals require you to give it the mob. So that's a float goal. So now if our entity falls in water, it's going to float. That's it. Flat out. So anyway, the easiest way to do this, instead of thinking up all of your own goals, is to go find an entity that does something close to what you want and take their code. So you have a lizard. What's it do? It probably does about the same things as it just walks around and I'd say it's like a cow. So we're going to go to the cow. That's not the right cow. That's a clipboard owner. That one. So you can see right here at the very top, it just registers goals. So we're just going to take all of these and steal them. So we already have a float goal. We definitely don't So, what kind of food do we think the lizard would like? What do lizards eat? Plants?
Yeah, definitely.
Hold on. What do lizards eat?
Herbivore.
Fruits and vegetables. Worms.
Depends on the species. Listen.
Worms. They like worms, guys. Worms and bugs. Guys, we have to add worms and bugs now.
We gotta eat the heavenly.
Since spiders can never make spider eyes.
Yeah, we'll do spider eyes. I think that's a good one. So we're gonna also change the food to stack.item. So we're just gonna do spider eye. So we're also right here. This is part of ageable mob. It lets us like create a new lizard when it breeds. So we can just create one here like that. And that should give us a lizard when it breeds. And then this is food is used by the breeding system to determine if it can eat the food that you feed it. So now it's tempted by spider eyes and it will eat spider eyes and then breed and then create a new lizard. And then you have, let's see, we have breed goal, panic goal, tempt goal, follow the parent, random walk around, look at players, and then random look around. I think that's a good set of goals for this guy. So now we have our lizard. I'm going to remove this annotation here because I don't like nullable annotations in Java. They're kind of bad. So now our lizard has some goals. And I'm going to do a little bit more talking about goals. I have some other slides here. No, that's brains. I guess I didn't do more about goals. So if you actually look at a goal, here are the methods that a goal has. So if you want to create your own goal, you can literally just make a class that extends goal. And here are the main things. You have start, which runs when the goal is about to start, and stop, which runs when it ends. And you have tick, which runs every single tick that the goal was running. Requires update every tick, which determines if it will actually run tick every single tick, or it will do it by this delay here. And you have can use and can continue to use. So by default, can continue to use is the same as can use, but you can make it different. Can use is what determines if the goal is ready to execute. So for example, in order to wander, the entity has to have valid blocks which it can pathfind to. So that would be a condition that determines if it can execute. I think better is like tempt goal, right? This goal that finds players holding a specific item. It has its can use is has a cooldown, and then it checks for nearby players. And if there's a nearby player, then it starts executing, right? And then when it starts, it looks for the player, and then every single tick, it looks at the player and moves towards them. And then there's the should follow, which determines if it can follow the player. It has these targeting conditions. So yeah, so it gets the nearest player that meets the targeting conditions, and the targeting conditions is this, should follow. And that tests if the item matches the item here, which would be spider eye. So that's a little bit of an overview of how goals work. And then you can see all the priorities here in order. So very first priority is it will float. So if you're tempting it, but it's in water, it's going to try floating first. Now float is actually not excluded from move. It's actually a jump because you're just going up. So that's why you can both float and move at the same time. So that's a little bit of how goals work. Actually, I guess we could probably make a custom goal. I think that would be fun. How about where the lizard just explodes if you feed it a fermented spider eye? How about that one? That's not a goal though. So that would be actually just an override of the interact, because goals usually require ticking. There's no point in making that a goal because it's not excluded from any other task. I could make it slowly like have a fuse. So like you feed it a fermented spider eye and then a goal starts executing that like makes it like progressively like grow. It's gonna grow and then it explodes. And that also lets me do a little bit I want to talk about syncing data between the server and the client, because any variables that you store on the server, the client has no idea. So if I wanted to render something and that depends on a variable on the server, it actually wouldn't update on the client because you have to send that information. So I can talk a little bit about syncing data between the client and the server so you can render stuff depending on the server's behavior.
So I actually have a question.
What?
So the data that's already currently synced by the client server relationship is just like
So yes, the
where?
server sends a few packets related to entities. What is... Oh yeah, their AIs are working. The movement speed is way too high though. Oh my god.
I don't know what you're talking about.
I agree, I hear this.
Look at these little guys. Look at them go. They're adorable.
They'll follow you.
Oh yes, yes, yes. I need a spider eye. What? Oh, what? Okay. Oh, oh no. Oh, oh no. Hold on, guys. I know what to do. I have a lizard swarm. This is my lizard army. Oh, they're dying. Hold on. There we go. There's so many of them. Lead them into lava.
See what happens.
Oh no.
Oh. Didn't mean to do that. Okay. Hello, guys.
They still follow you.
They're on fire. They're so fast. This is awesome. Thank you. Thank you, guys. Oh, there's more. Hey, guys. I got you a present.
Leave it to lava.
So much fire.
Oh, I know what we need. Oh, I know. All right, I'm just gonna send them a little message. Don't mess with me.
Make it a river clock.
Observer clock, you're right, you're right.
Wait, if you give a
I forgot how to make these.
So you put yeah.
Hold on, I need them to go away.
Other way around.
Oh.
Yeah, so you want the.
Okay, got it.
Yeah.
Now what? Oh, it's working. Utter chaos.
Get the spider eye.
Hold on. There it's hitting a wall.
My computer wouldn't love that.
Annihilation. Hold on, you know what this needs? The cannon. This was a great... We just really like exploding things here. Okay, so now we're gonna do some more fun stuff. So, I'm gonna do the last part of my lecture, which is brains. So brains are like a more complex version of goals that was added recently. So like, for example, axolotls use this to make more advanced like conditions. So they store memories, which are structured variables that control and inform the behavior. So like a villager will remember its bed location, its job block, and some of them are like related like cooldowns or other sort of things like that. So you'll see here with the play dead goal, that's the axolotl as a play dead. They're not called goals, they're called behaviors. It checks if there's a play dead ticks value, and it checks if it's been hurt by something, and then it plays dead. So then these goals, the brain can store a schedule which determines certain tasks. So villagers have a bedtime, and then instead of goals, you have activities and behaviors which are very similar. They have like the same like start, tick, stop, and then conditions, but they are a little bit different. And they can have a duration here, which play dead runs for 200 ticks. I believe that's like 10 seconds. So I haven't actually used a brain for anything, so I'm not going to cover it, but those exist, and if you want more complex logic there. So now we get to do more fun stuff. So in terms of making the lizard explode when you feed it something, first we're gonna like catch the code for feeding it. So if we do override, and then there should be like interact. Yes, use player item, I believe. So if you look at this, it consumes it. No, that's not what I want. I want mob interact. So mob interact will catch any interactions with the player. It gets their item, checks if it's food. So this is for the ageable mob. It checks if it's food and then does the breeding behavior, right? But in this case, I'm going to steal this code and I'm going to do something totally different with it. So if it is, if the item stack get item is a fermented spider eye rather than a spider eye, because God forbid you feed it alcohol, it explodes. How dare you feed it alcohol? So if it's not running on the client, so if we're running on the server, then we're going to do this dot. So now we can do whatever we want. So get ready to explode. So we're going to store a little variable because entities are so fun in that they can store their own variables. So private int ticks to explode. And we're going to set this to -1. So that's its default state. It's not going to explode. So then when it's ready to explode, we can make a function. We're going to do it public void, or I guess we're going to, yeah, public void set ready, or make explode. And then this will do this dot ticks to explode equals, and then how long will it take to explode?
5.
10 seconds? We're going to do 10 seconds, so that's 200 ticks. A tick is 20 per second, ideally. So 20 times 10 is 10 seconds. So then we're going to do this dot make explode. What?
I think if you make the entities hitbox like really small, that is entity cramming. I'm thinking about it like
Actually, so I'm not actually going to put ticks to explode there. I'm just going to do ready to explode. And that reason is because we're going to make a goal, and that's going to store the ticks, I think. No, because we actually want it on the client. So we're not going to make a custom goal. I'm going to talk about how data syncing works, rather. So we also, here's the thing, if you feed it a fermented spider eye and then you immediately exit the world, this variable will not get saved to the disk. So then it would just eat your fermented spider eye and then never explode if you exited the world. So I'm going to talk about how entities save data, because they can actually save their own data, which is really fun. Fun part of entities. So if I do override, there is a function called read additional save data, right? And then you also have write additional save data, or it's add additional save data. So this lets us add on. So if we look in the animal, it's saving whether it's in love and that sort of thing using this compound here. So compound is an NBT compound tag, which if you remember my lecture about NBT from the, I think, blocks or items, I don't know. NBT is Minecraft's data storage format. So in read additional save data, we get to read from the compound. So this dot ticks to explode is going to be compound.get int ticks to explode, and that's the key we're going to use. And then add additional save data, we can write it. So So it's going to be compound dot put int ticks to explode. And oh my god, the code recommender is actually really good. The new IntelliJ code recommendation is solid. So there we go. Now we've got ticks to explode is being read and written to the disk. So that's only the disk on the server. So now if I were to exit the world and then rejoin, that number is going to persist. That's really important. But if I go on the client, right, and I go to the renderer, and I want to adjust its scale by how many ticks it has to explode, right? So we can do float scale adjustment, right? And we can do math.lerp, no, math.util, hold on, lerp. I know the game has a lerp. Math.lerp. So lerp stands for linear interpolation. It's a math concept. It's where you have 2 points and then you have a number from 0 to 1 that describes your trajectory along that line. So you have delta, which is the trajectory, so how ready it is to explode. So we're going to do out of 200 ticks, how many ticks left to explode. So if we do living entity, that would dot ticks to explode. So we'll see that ticks to explode is actually private, so we can't read it. I'm going to make a getter. And then our minimum is going to be, how about we say at maximum it can double in size, so it'll be 0.5. So from 0 to 0.5, we can add the scale adjustment. So do, if it's greater than 0, then we'll lerp. Otherwise, we're just going to return 0. And we're going to add the scale adjustment to everything. So now let's see. So we'll have 200 ticks. That's, and I actually want to do the inverse of this. So it's going to be 200 divided by get ticks to explode. And then we'll notice that it's greater than 0 because there's a possibility of having a divide by 0 error here. So we have to first make sure it's greater than 0 before we do that. So that means, let's see, 200 divided by 199. No, that's still not right. It's, I want 1 minus this divided by 200. So that's going to be at 199 ticks, it's going to be almost 1. So then 1 minus that will be 0. So then we're going to have a start of 0. Yes. Yes, that is correct. And then I actually want this in floats. So make those into float constants. Okay. Hooray. I think that should do it. So I've just added the code to make it like grow, right? But if we run this, it's actually going to stay at, it's never going to grow when we tell it to explode. And that's because the data doesn't exist on the client. The client, for all its intents and purposes, thinks this is still -1. Why? Because make explode doesn't get called on the client. It only gets called on the server right here. So that just doesn't do, it doesn't know. So now we get to learn about a fun Minecraft concept called synced entity data.
I love to work.
Yeah, see ya. So I'm actually just going to boot it up for demonstration purposes to show you that it doesn't work. Also, we actually need to make it explode. I forgot to do that. So if we override, there's a method called tick, right? So this will run every single tick that the entity is alive, right? So then we can do if this dot ticks dot to explode is greater than -1, then we can do minus this dot ticks to explode, so that will remove 1, right? If this dot ticks to explode is equal to 0, then we can explode. Okay, so now it'll explode when ticks to explode is equal to 0, and then set ticks to explode to -1, and then this dot die. Damage sources are really weird now. I have no idea how to do this. That would do it. It's this dot damage sources. We're just gonna make it die from generic damage. So now it'll explode and then die. Hooray. And actually we can just keep ticks to explode at 0 because, hold on. Yeah, so now we can just keep it at 0 because it'll die. And so, yeah, it'll work on the server, but you won't be able to see the changes on the client. And I'll just demonstrate that. But while we're doing that, we're going to talk about the sync data. So if you actually look, if you think about it, so a wolf, right, it has a collar. And you can change the color of that collar by feeding it different dyes, or not feeding it, but giving it different dyes. So that's a really good example of the type of logic that needs to be synced with the client, because the client would have no idea what color the wolf's collar is. So if you look at the wolf, it actually has this collar data here. It uses synced entity data, right? And so you'll see that down here, it also registers inside of defined synced data what the color's default value is, red. So we can do the same exact thing. So we can just steal this code here. But first we're going to look at our lizard. Oh, I forgot about the chaos that was unfolding. So we need a fermented spider eye. And then we can summon a lizard or just use one of them. So, hello lizard, come here. Okay, so if I give it a fermented spider eye, right, and then we wait 10 seconds. Kablam! So you'll see he didn't grow, and now he's just stuck there sideways and dead. What? You're supposed to be dead, lizard. I guess he didn't die fully? How is that even possible? How are you half dead? Okay, well, so it didn't die for some reason? Oh, I didn't set its health to 0. Okay. How do I deal? Oh, it's attack. Right? How do I deal damage to this thing? Okay, you know what? I'm just gonna do that. So now we have to sync the data. So I stole that code from the wolf. Let me just put that in here. And we're gonna do this data ticks to explode. And then, so very important, this right here this is very important. Make sure this always matches the class that you define it in. Otherwise, the data engine is going to get really confused because that basically ties it to your entity type. So you need to make sure that's correct. And then you have to register it. So if we do override, we want define synced data. Yep. And then this builder, you can define data ticks to explode, and then its default value, which will be ticks to explode's -1, right? And so then when you do make explode, you're also going to want to set the synced data. So you can do this dot set sync, or is it set data, right? No. I forgot how this works. We're going to look at the wolf again. It's this dot entity data. Okay. So when you do make explode, you need to do this dot entity data dot set data ticks to explode to ticks to explode, right? And then when you get it, this will work, but not on the client. So we're going to do the same thing, but just make sure that this specifies for the client. And then change it there, because nothing else actually uses that method. So get ticks to explode for the client. And then this also here is adjusting ticks to explode. So we should do set. So that will update it as well on the client. So now that we have the getter and setter for the client sync data and it's registered with this method here, we can actually use the data inside the renderer. Boom. So, yeah, boom. So now if we boot this new version up, it should grow gradually as it's preparing to explode. I'm really excited for this. This is going to be really funny. What if it also like shifted like purple? What if it started turning purple? I think that would be really funny. All right, which friend shall we subject? Which friend? I think this friend looks very hungry. Hello, friend. Oh, that's awesome. Oh, where'd he go? He's running. He's trying to get away. Oh, there he is. He blew up the dispenser. I feel like this needs to it needs to gradually get larger, in my opinion. Also, I made a logic error. You can actually feed it multiple fermented spider eyes. So I think it needs to get larger. 2, it needs to not accept multiple. So if we go to lizard entity and then make sure it's not already exploding. So if it's currently not exploding. Oh yeah, we also need to make sure that it actually, so this will run on the client as well. So we need to use the client one instead. There we go. Now it won't explode if you've already fed it one. So now we can, what was I doing? Oh yeah, I wanted to make it explode, like, I wanted it to like scale up as it gets closer. So we can use a approach, I think. No. So we can use the power of math to make like an exponential curve that's clamped. So if we boot up Desmos, I think we can have some fun. So we basically want an equation that goes like that, and that's going to be, I think, like 2 to the x. Yeah. So we need to shift this so that it goes 0 to 1. That looks pretty perfect. I might want x squared, actually. Two x squared? Yes. So yes, I want 2x squared in my opinion. I think that's a good idea. So if I do so if I take this number and then do like 2, so 1 minus this number, and we can do math.clamp from this number from 0 to 1, and then we can do math.pow, which is, that's how you do squared. That's a double? Okay. Well, not my problem. Cool. Oh, that's why it's math. There we go. So now we have, it's clamping this power from 0 to 1. And I want it to get like up to 2 times larger. So now it will gradually get faster. And then I also want the, I want it to turn purple. So we can actually do that right here. There's this color here, right? So if I do, we can actually adjust the color. So if we multiply it by FF00FF, that should turn it purple, but because that's called color multiplication, but we're gonna get a color picker, and we're gonna find purple out here. What's the purple shade we want? I think like
I want a more, well, I want something a little closer to blue, like deep purple.
like this. Yeah, I think that might be good, like that. So if we make it like this shade, we'll tint it this shade of purple. Then we can do right. So that will do color multiplication. So it'll blend using multiply blending. But we only want to do that if it's like currently exploding, and we want to do like, we want it to fade from white. And so white is, we can do a lerp. Another lerp. So if we lerp from color to color times that, right? Then we can take this code here and use that as the base. So we actually don't have the entity. So here's a fun thing about this render to buffer. It doesn't give you the entity, but setup anim runs right before it, so you can actually store it here. private int ticks to explode is -1. And we can do this dot ticks to explode equals entity dot get ticks to explode client. So now this model will update this field, and then we can use this field right here. Oh, so math.lerp is for floats, not integers. So it's giving me shit. So let's see, if is greater than -1, then we'll do that.
See you later.
See ya.
Bye.
Otherwise, we're just gonna do color. Nope. Otherwise, color. So now it will gradually tint purple, hopefully. So I know I said earlier that you shouldn't store data in the model, but because setup anim is called every frame, this will always be up to date. So we can actually store data in that short term there. Okay, so now let's feed one of our friends a fermented spider eye. I think you look like a good candidate, if you would stop moving. How about this one? Oh, wow. Not only is he turning purple, he's turning every color in the alphabet. So the lerp, the way the lerp is working, it's lerping over a combined RGB space. So I didn't actually interpret color space correctly. Correctly. So it's actually lerping between integer numbers, but not in a linear fashion within RGB color space. So like this, it's going basically like down in numbers, but that doesn't necessarily like linearly affect its color. So like this is an actual, that's being interpreted as a number. So like, so it's going up 1, but that might add to the blue, and then you go up like 20, and then that adds to the green, and you go up 40 and adds to the red. So it's, yeah, that's what's going on there. I would have to separate them into RGB space and then combine them back together, and that's too much effort. So I'm gonna stick with this crappy lerp. I like how it looks anyway. It does turn purple eventually. And notice now we can't feed it multiple. So that's cool. I want them to get like way bigger. Yes, the Jeb sheep actually do a similar thing. I was just thinking about that actually. So if you look at the sheep renderer, the wool sheep fur layer, so if you name it Jeb, it iterates over the dye colors and then loops around them. So not really, it does a lerp, yeah, there's a lerp going on. But that fades between two set colors. So it's actually, there's already a color lerp built in here, so I could probably actually use that. Yeah, I'm gonna do that actually. That's kind of convenient. So if I go into the model here and then change this math.lerp to a fast color lerp, that should do exactly what I want. And then I also want it to get way bigger. So we're gonna do like up to 4 times larger, and then we'll do 2 times that power. Yeah. That should accomplish what I want with the power of math. I love the stupid NeoForge loading screen. That fox is awesome. Oh my god. So the iteration doesn't really seem to be working with the color. Well, actually, it is working. It's just kind of slow. Yeah, no, it's working. It's just not applying the color deeply enough, in my opinion. I think that's because I've actually done it wrong. So I'm multiplying the color. I think I just want to put the color like flat out. But otherwise, I actually think that's perfect. I think it's doing exactly what I want it to. So a fun thing about this data being saved now, you'll notice that when I loaded it in, it was already exploding. That's because the data is saved. I can do some fun things with command blocks now, where we can actually give it NBT data. So we can change ticks to explode to like 50, right? Wow, we're gonna do 3 seconds. So that's 20 times 3 is 60. So now they'll spawn in ready to explode. You guys, oh wow, beautiful. They exploded their own lever. And the lava's coming for them now too.
I love it.
That's so silly. The world is just exploding lizards. Oh, they blew up the lever. That's no fun. Oh, they're dying before they can... Hold on, they need water. Oh, that'll block the explosions. No. How could you?
Put something like
What if I just make them explode, like, in a second? Oh, that's much better. They're just exploding constantly. This is terrible. All right. Well, I think I accomplished everything I wanted to today. We didn't really get to talk about the rest of my topics, which are, we got through that. Navigators, movement helpers, natural spawning, and spawn eggs. So those will be like for later. And animations, which are actually kind of complicated. So that's a later topic as well. But yeah, this has been good. I think I'm going to end the presentation now. Thank you all for coming.